Hello everyone, my name is Atharva. Today I am going to explain an important topic that is optimization of loss function and best fit line using gradient descent. So now this topic might sound a bit technical, but we don't worry. I will explain it in simple and easy way. So the introduction is that the computer learn by improving their prediction step by step. The main goal of this process is to find best possible solution for the given data. This process is called optimization, basically making something as perfect as possible. One of the most important methods used for optimization in machine learning is gradient descent. You can think of it as the learning engine of a computer. So what is the best fit line? Let us understand it. Imagine we have the data showing how many hours students study and the marks they get. If we plot this on the graph, the point will not form a straight line. Some points will be higher, while some are lower. Now we want to draw one line that passes as close as possible to all these points. That line is called as the best fit line. This line shows the relationship between study hours and marks, and it helps us to predict the future results. For example, if a new student studies 5 hours, we can predict his marks using this line. And this line helps us make accurate predictions. Why do we need optimization? There are many possible lines we can draw through those points. So how do we know which one is the best fit? So to find out, we need to measure how wrong each line is. This means we must check how far the predicted values are from the actual ones. And there's where loss function comes in. And it helps us to calculate the error and tell how well or poorly our line fit the data. So what is the loss function? It measures how far our predictions are from the real answers. So if the difference is large, the loss is high. That means our line is not fitting properly. If the difference is small, the loss is low. This means our line is quite accurate. So the goal is simple. We want to minimize the loss. In simple words, to reduce the error as much as possible. So what is the role of the gradient descent? To reduce the loss automatically, we use this gradient descent. Let's take a very simple example. Imagine you are standing on a hill in foggy weather and you want to reach the bottom. You can't see far. So what do? You take small steps in the direction where the slope is down. Then you check again and take another step downward. You keep going this until you reach the lowest point. That lowest point is where the ground is minimum. And in our case, this means minimum loss. So, in gradient descent, the computer does exactly this. It keeps adjusting step by step until it reaches the lowest loss, which gives us the best fit line. How the gradient descent works? So let's go through. We will start with a random line, then we calculate how much loss that line has. Then we go for checking which direction the loss decreases. Next we take a small step in that direction. That's an update, means update line. We repeat this process again and again. Each time the line changes a little and the loss becomes smaller. Finally we reach the point where the loss cannot be reduced anymore, and that's our best fit line. Next, the learning rate. There's one very important concept, that is learning rate. So this means the step size we take while moving down the slope. If the step is too large, we might jump over the lowest point and miss the best solution. So if it's too small, it will take a very long time to reach the bottom. So the learning rate has to be just right, not too big, not too small. It must be balanced. So now we see the step-by-step summary of these slides. So we first take the data points, we draw a random line, we calculate their loss, then we adjust the line, that is we can tilt it or shift it. Then we check if the loss decreases or not. It keeps repeating this until the loss stops changing. And that at that point we found that the best possible line, the one with the minimum loss. So here are some applications of gradient descent. So gradient descent is not a small concept. It used in almost everywhere in machine learning. It is used to train neural networks, which power AI models, also in image recognition, like identifying faces or objects, in voice recognition, like Alexa and Siri, ChatGPT, Google Translate, self-driving cars, and much more. Basically, wherever a machine needs to learn from data and improve gradient descent is working behind the scenes. Thank you for watching the video.